So the idea of telecommunication is the following. So let's say I will draw just the map of United States, something like this. All right? And in this map, in the very significant areas, for example, in New York, in the Washington, in Miami Beach, in Chicago, in Seattle, in the north, and in Texas, and in other points, that is the cities, right? Cities of United States. Even in Toronto, Canada, that will be here somewhere, and in Vancouver, Canada, because Canada is American satellite, will be installed the computerized communication center. And in these centers will contain not only computers, that it will be communication facilities and communication lines. So every center will be connected to every center with cable communication line. So folks, what I'm going to do, I will put these communication lines between all of these centers, and you will see cities that connected to each other. Look at this. And this connection is not a telephone connection because telephone connection is communication of the cables. When you dial, you actually communicate with the cable, so the telephone permanently is not connected. But this is the permanent connection of computers. Look at this, folks. Every one with each one. And then they created such a network diagram. Network diagram. So that is center, that is center of communication, that is center of communication. And every city will have center of communication. Some big cities will have more than one. For example, New York City must have more than one. Okay, this infrastructure will give opportunity to use the computers to send and receive messages. But folks, computers at that time were pretty slow. That was in 1965. And slow computers, actually, and big computers, were pretty slow. And messages that we know how today's emails could come through the communication line pretty slow. So to make messages to withstand against nuclear warfare, the message itself that transmitted from one computer to another, the message itself must be short, because during short message, computer cannot be destroyed. But what is the idea of this messaging network? Let me explain. Consider that this everything is good and all the messaging centers are working well. So every center can send and receive message with different center. But if one of these centers destroyed, for example, this one is eliminated from the list, then the attempt to communicate with it will be unsuccessful. And this intelligent center will understand that it cannot communicate with destroyed center. And as soon as it cannot be, it will use the bending route to go from itself, from himself, to the addressee, not directly, but using survived communication centers. All right, to make this transmission successful, the document that must be transmitted supposed to be cut to the fragments. Consider that this is a document, folks. The big document, let's say, is 25 pages, right? 25 pages. But this document must be cut with kind of electronic scissors to the very small fragments. And look what's happened next. Every fragment must have its own unique number. Then, every communication center must have its unique number, like telephone number. This unique number named IP address. IP address, IP address, IP address. What that meaning? IP address looks like this, folks. 112.86.267.13. This is unique number of this communication unit. And every unit in the country have unique number like telephone number of the IP address. Then the map, the entire map with all IP addresses must be in the brain of each computer. This map named routing system. Routing system. So how these computers connected, the entire map, and where computers with a certain IP address, it's actually is sitting in the brain of these computers. All right. Then, when we actually cut the entire document to the small fragments, each fragment must have a specific information on it. That is the name of the document, today's date, number of the fragment, okay? Then IP of sender, IP of recipient, and many other information and current information that actually here in this fragment. For example, you would like to send email to your mom. In this email, you will say, dear mom, please, could you send me $200 because in McGarry's College, the books are very expensive and I'm actually broke and I need some money. So how this message will look after it will be created of the small fragments. That will be, dear mom, cut. I'm writing you cut because in Medgar's College, cut. Books are very expensive, cut. You understand, right? So these small packages, but they get a name, packages. Small packages could be transmitted pretty fast. But take a look. Consider that this document came to the computer, which is sender. I will make this computer with red mark on it. This computer has number of packages. I forgot to tell you that, folks. The total number of packages also will be in a title of each package. So how it looks like? It's not like this computer already know who will receive this little message from it, but it rather asks all surrounded computers like this. Guys, I'm here, I have packages. Anybody can get my first package? And computer that is actually free of different job can tell that I am in charge so I can get your package. And I will show you computer that get the first answer. So the first package will go to this computer. But during this time, other computer became free of duty, and the next operation will be asking again, guys, computers around, could you tell me who is free of duty right now? And the nearest computer will say, I am. And the next package, so that is the first, next, second, will send to it. These packages which been sent to the nearest computers, here, nearest computers, folks, they will not stand on these computers, not even the short time, because these computers now on duty to send these packages further. How they know where further? Because the routing system will tell them the direction which they need to use to send these packages further. And immediately after that, it's like a burning hands, the package will be sent further. And further and further and further. So you will see the wave of packages that going through the different computers. And you never can tell which computer will take it first, which computer will take it second, and what's happened after the second computer will ask his brothers to take these packages from the hand and send it further. That actually will go further and further and further stochastically. It's like happened in this way, but next time it will happen with another way. IP, it's like unique telephone number of each computer, but it's not through the telephone, through the network. IP is information protocol, folks. IP, I will tell you about information protocol in a moment. IP is actually the unique number of the computer or each computer on the network. So consider that this is recipient and this computer must have the document after being sent from any other computers. This one, like computer in Seattle. So this computer get the first package and the first package will identify itself, I mean this computer, as a recipient. So it will save the first pack. Then it will save the second pack. Then it will save the package number 13. Then it will save the package number 24. Why are they coming randomly? Because they goes through the different roads, folks. The roads will be absolutely different. One road will be longer than another. So these packages will come with a different time. And eventually, when all the packages will be concentrated on the recipient end, then the document will be glued together. It will be integrated from the small packages. And then you can hear, you got mail, all right? Your email will be ready for you to be seen on the computer. Folks, when computer communicate with other computer, that is a specific artificial intelligent system that allows computer identify itself, to find the nearest computer for the communication, to ask this to open ports for the communication, send one message with packages, and then stop communication. This actually the rule of communication named protocol. If you have a net protocol is the program that defines the rules of telecommunication between communicated computers. So the protocol is a main intelligence part of the communication. And every computer actually connected with protocol. So every computer have the artificial intelligence as a protocol programs. But protocols supply this computer for the different situation. For example, the protocol of recipient could be a program that defined the actions of this computer when it collected all the packages and created the document. But what's happened with the protocol, how protocol dictate what to do if some of the packages didn't come. That is very interesting because when some of the packages didn't come, we cannot integrate document. Document could not be created. So the computer that find out that some of the packages didn't come, send the message to the nearest computer with IP of the sender to ask to resend the lost packages. And question why these packages lost online? Because the communication center lose information. Why communication center lose information? Because of the power outage, because of the destruction that came as a result of nuclear warfare. Okay? So when the sender, if sender is still alive, is receiving the request to resend information, it will resend a certain lost packages from here, not entire document, just the lost packages. And when the lost packages came through the network, the document is integrated and totally received. So folks, I will now get another page of paper so you will be able to see the next picture. All right, so now what kind of protocols actually computers must have to create a telecommunication between each other? One of the very important protocol named TCP/IP. Folks, let me explain what is TCP. TCP is how these computers, how they are supposed to communicate. So how to call somebody, how to shake hands, how to ask, could you please take one package? So this TCP is Transmission Control Protocol. I will write it down. Transmission Control Protocol. By the way, you can write definition what is protocol. So folks, protocol is a program of behavior of each computer online. It's a program that defines the behavior of each computer. So transmission control protocol. What is IP protocol, folks? It's Internet Protocol. Internet Protocol. So actual transmission control protocol and Internet Protocol, it's two protocols and they define the mission of each computer online, how to send and receive packages. The overall communication of this system named communication of packages, because packages is a small fraction of the document that could be transmitted independently. Then you need to understand that on this network picture, all the computers already in a fixed position. What's mean in a fixed position? Somewhere in a bunker, somewhere underground, and telecommunication facilities and cables also protected. Energy also protected. It's independent from the national grid of the powers. So folks, TCP/IP. TCP/IP is communication protocol. What other protocol we must have online? When you send and receive file, so that will be file transfer protocol, FTP, file transfer protocol. Send file and receive file, file transfer protocol. So folks, when you're working with email, that will be SMTP. SMTP is a small mail transfer protocol. So this is work with email and work with email addresses. By the way, one IP address is unique number of computer on net. One IP address computer can have many email addresses that connected to it. I will tell you later what it is, folks, in the next session. So that is all protocols, but the family of the protocols, they are exceeded. So it's much more protocols. So this network was successfully tested and it was worked for the military purpose, for Pentagon and other military facilities. But what's happened in 70s, unfortunately, this facility was compromised by Russian spies. It's been very sad situation for developers because they must develop something more secret that could used by the confidential networking. But what's happened with this first network? Folks, the first network get the name, the net, and this name, folks, is ARPANET, the first network that was created in the United States. But when it was compromised, the owners, they decided to give it away. What's mean? The facility already been done. So they made all of these protocols, TCP/IP, and FTP, and SMTP, and IP addresses. They open it for the public and gave it to different country. And different country immediately start build the same systems in their country and build the cable through the Atlantic Sea and so on. And they create internet from this ARPANET. So that meaning that not only United States system like this, the unique system existed on the world, but other countries immediately started doing the same thing. And ARPANET became internet, and all the rules became publicly accessible. So people start getting internet access and email access and so on and so on, start public communication. But question, how the system know that other system is connected to it? Because other system, folks, it's nothing but another computer which connected with a cable or satellite or a radio system to this computer. And when this computer actually starts, it will send the protocol of existence to the nearest computer, meaning, hello guys, I'm a new guy on the block. I'm here to communicate with you in the future. And then what's happened? In the routing table, but routing, folks, routing system It's a map of all computers online. They will add new computer. So they will add new machine, new computer to the communication system. How they add? That will be where and its IP. So one by one, when you open this network description in the content 2, I believe it's there, you will see the first telecommunication network like ARPANET was contain about 160, 170 computers. But contemporary internet contain about 8 billion computers and more every day. That is automatically connected to the internet different countries. So folks, the question of description, what is internet? So internet is international telecommunication system applied with telecommunication computers, facilities, cables, and most important, protocols. Folks, can this system be functioned without human? Yes, a certain time it can. Until everything works okay, it's automatic. Now, this is actually, so now you understand that internet actually working without human attendance, and it can work and withstand technical and warfare destruction if even in this diagram one or two computers are not working online, then computer that works with it immediately retake these packages because this one is not answering. So it looks like this. Take a look, folks. For example, I'm the computer that have about 20 packages, and I ask some of you. For example, you are my computers, right? And I ask Kristen, hey, Kristen, are you ready to get the first package? And Kristen said, yes, I'm free of charge now, so I can. So I said, I will send it first to you. Kristen said, yes, send, I will receive it. Then send. Kristen said, receiving. I will go for George. George, are you ready to get my second one? Joe said, no, I'm busy. Then I go to Desika. Desika, can you get my second one? Desika, yes, I can. I will send it to you. Simultaneously, I'll go to Mamadou. Can you take my third one? Mamadou, no, I cannot. Then George said, I'm free of charge now, I can. So you see how it happened. It's pretty fast, folks. And then Desika, Kristen, Mamadou, George, all these computers, all these telecommunication systems station, they immediately will ask nearest computers, maybe that will be people from another class, maybe it will be computers from another area. Uh, Guys, can you get our messages? Can you get our packages? So the wave of the packages will go through the country pretty fast. Folks, I will tell you that about 50, 100 packages with the pictures, with everything, in a binary form will go from one area to another area in the United States in minutes. If you need to bring it physically, it will take a year, right? But without um, physical availability, but only electronic messages, it will go in a minutes or seconds. All right. So again, uh, telecommunication network like this, named Internet, International Network. It's a skeleton of telecommunication facilities, stations, computers that actually provide basis of telecommunication for everything that we need sent and receive online. Now, how regular computer must be connected to the basic telecommunication stations. You know, these stations, folks, as I told you, the stations of telecommunication, they called also nodes, telecommunication node. So node is pretty expensive, big computer. By the way, folks, every computer on a node named has a specific name. I will tell you that is servers. What is server? Server is like a regular computer, but it's bigger, more reliable, more expensive. And this server computer actually work faster and more reliable than any desktop or laptop computer. And server also has usually a telecommunication facility that allows server to connect more smaller computers to server. So let me change the page and I will show you how server connected to the regular computers. Okay, consider this is our server. So we have a screen as a computer and we have computer body, and that is actually server. So the general communication line goes to this server with a thick cable, like in our college, that is cable that go through the basement, and this cable is very expensive. This is type of cable named fiber optics. This is contemporary cable. And folks, the provider of our communication is a massive telecommunication facility. I know that we coming from the server like this from Verizon. And Verizon could connect to AT&T server like this. So you can see that in a nationwide system, nobody like you and me can play significant role in the telecommunication system because the big players like AT&T, T-Mobile, and Verizon can play significant role in this telecommunication. Optimum Online, which is also here on these telecommunication facilities. So this, folks, is network. But how we supposed to be connected to this system? We are quite small, and that is my computer, my laptop, or my desktop, which I use to connect to you. And I am located in the little apartment in Cope City. So this server, folks, let's say this is Optimum Online, provide the concentrator. That concentrator is the specific board that allows many people to create subnetwork, folks. Subnetwork. And that subnetwork will connect me, you, somebody else to this. Actually, I pay monthly payment for this. And you will pay monthly payment for telecommunication facility. Who is your provider, folks? Can you tell me? T-Mobile, okay. Optimum, like me. Okay, I'm in Bronx, folks, and also I have Optimum telecommunication provider. But folks, my friend in upstate New York, they have Spectrum. Spectrum also a very famous one, and that is actually a lot of providers. But you need to consider this subnetwork that allows you and other people to be connected, to be connected. Folks, this subnetwork, which actually connected under one roof in one building, let's say that is a building, right? I'll put it here. That is a building. So this building, folks, provide telecommunication named Local Area Network, or abbreviation is LAN, Local Area Network. So take a look, folks. This local area network, what is the structure of this local area network? I'll put it here. Consider this. This is me, this is you, this is other computer. This is three computers, three small computers, three small computers. Can you see these dots? That is small computers in one building. Then they must be connected to the server inside of this building. Where the server? This server, this server, this another building will use another subserver that will be like this, and I will say, and here also in separate building, another server. And the third building, we use subserver that connect these two computers. All right? How these servers must be connected to the general server. So few buildings actually connected to the server that will be a little bit higher than this, and they will connect it this way. If you have nearest telecommunication system like this, these two servers connected to another server. So to connect these two servers, we need to have another server like this. So folks, what we got actually, this system is named hierarchical system. Hierarchical. Hierarchical. Hierarchical, folks, meaning the system like a pyramid. So the college and the army and the country is hierarchical system. What's mean hierarchical, folks? That we have supreme server, supreme the huge one, like a chief of everything, like a president of United States, like a president of the college. All right. So all of this system is under his supervision. Then you have vice presidents or lower level servers. Then you have generals and marshals like these servers. And then eventually you have a private, but before private, that will be colonels, lieutenants, and eventually private soldiers that doing their functions, like our local computers. So this is, folks, local area network. And local area network has a specific protocol for local area networks named Ethernet. It's not like TCP/IP. It is different. This is Ethernet, local area network. And this communication named hierarchical. So what type of network, what type of local area network we can find out? In the very early time, that was circle of connection in a room, for example, and computers were connected to this circle. Can you see it? And this circle of connection named token ring. That is very archaic token ring. That is token ring. But you need to know this type of communication because in the very old communication systems in the local area network LAN, this system still exists. So uh, what actually the idea of it? When computer number one would like to speak with computer number two, all right, the entire line will be busy and a line will be occupied, and these computers, other computers, computer number two, computer number three, that is computer number four, will not be able to speak with each other. All right, so this is not good. Another communication is communication named STAR. STAR communication is when the communication facility is could be done with only one computer that's specifically doing communication things and named server. It's what we're talking about, and other computers will be connected to server. That named star communication, star structure. The star and star and star, so when we're doing this is server, this is server, and 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 this is local computers. This is local computers, okay? So this system named hierarchical. This is different system of local area network. So this is three different types of network. Another one, folks, named bus. Bus is like this, also very archaic. So bus is a line and all computers just connected as a line computers. This is not very good, this too. But the star and hierarchical are practically very effective. But if these small computers could be also servers, so you can see the local computers that connected to these servers, and that will be also effective computer scheme, effective computer configuration. So when we know the the name local area network, we need to give the different definition for the internet. And internet, folks, is global interconnection of local networks. You can write it down if you would like to. So internet is global interconnection of local network. What is next, folks? So when internet became a very popular and servers became a more and more effective computers with a big storage, huge storage inside, and this storage actually was occupied only in a few percent of its real capacity. So for example, the hard drive of the computer, which is staying online like this one server, the hard drive of this computer could be occupied with information only on 10%. Why so? Because the packages are really pretty small. They going pretty fast. And then most of the time, the capacity of the storage is free of information. So people who actually create this system, they considered that this informational storage on this network storage could be more effectively used with information. But what kind of information and how people supposed to get this information? First, they put the governmental information on it. For example, Immigration Naturalization Service, criminal charging service, law service, and motor vehicles, medical insurance, pension and retirement centers, and more of this, right? So they put information on it. When they put information on it, that was a pretty good question. How regular people that actually sitting like you and me on the local computers, how these people can actually access this information, how you get this information from the server or to your local computer. And that was a very interesting question. So people immediately start developing the programs that actually works on the local computers and allows you to go to server and get information that saved on this server. And this program also allows you to find something. So that must be two functions. First, function is communication with the server, and second function is like a search. Search what? Whatever you need. Search the information. Search the information. So the first program that was created, named browser. The second program, folks, is a search engine. Search engine. What is the difference between these two? Folks, browser is a program that take residence on your personal computer. So this is local. This is local on your local computer. You're right. Search engine is cloud based, but cloud itself based on server. All right. So this is cloud. You correct. But cloud is a system of informational access that's sitting residentially on a servers. So the question that you find on exams, what is the basic difference between search engine and and the browser? And you can answer. The browser is actually a communication program that allows people to get connected their local computer with a server. And search engine is the program that's sitting on the server in the clouds that allows people to get information where information is allocated. Where information is allocated, on which server. For example, you need information on your summonses in motor vehicle. So you go to the browser? No. The browser, you go first because your computer need communication, you need to go to the communication to the server. So through the browser, you connect it to the server, like to the local network, and then through the local network, you will go to the global network. Okay? And cloud engine, search engine, actually like Google or Alta Vista or other like this, will give information where is motor vehicle website. Oops, I said website. Folks, now I need to give you definition of the website. Let me go for the web, folks. People who put information on servers, they had a big question about the job that will help people to figure out where and how to access information on the servers. So they create the new protocol, the protocol named HTTP. What is HTTP? First of all, to get information from server to server, they need to see not like the yellow book of servers. For example, this server dealing with phishing, and this server dealing with eBay, and this server dealing with Amazon. They all dealing with all these things. So HTTP looks like this. Take a look, folks. This is the text with pictures, and this is the first part. So take a look. This is the first part of information. For example, the textbook for the computer science textbook. This is actually sitting on the server with a certain IP address. Then, folks, when the first part, you read the first part of information, and the second part will go to the server number 2. That is IP2, that is IP1. and that will be part 2. Let's say part 2, and that is a textbook. So you need to connect them with a certain way. So what people designed, they put here the item named hyperlink. Hyperlink. The hyperlink is the address that provide jumping from information of this server to information on this server. So hyperlink actually shows allows your browser to show you information from IP1 and jump to IP2. This is link. You know how to click the link. Click here and you will see the second part of it. So this protocol, folks, named Hypertext Transfer Protocol, or HTTP. This is Hypertext Transfer Protocol. Hypertext Transfer Protocol. So this Hypertext Transfer Protocol, folks, is a part of your browser that's sitting in a browser. So browser can provide this jumping between these servers. So people will be able to jump from one server to another. Then these folks, after this one, will be linked to the third, to the part three, and that will be here. Okay, so this how World Wide Web is functioning. www. Whoever did the www, folks, named World Wide Web Consortium. They developed the HTTP protocol, and HTTP actually is a part of the URL. URL is uniformed locator. Why we use URL, folks? Because IP is very long information, but the form of URL is like this: HTTP hypertext transfer protocol colon then double slash, and then will be www, then dot, that will be the name of URL, uniform research locator, and then the extension. For example, HTTP colon double slash www.mec.cuny.edu. So that is actually to exchange IP address that we use for Medgar Evers College. So you can say some HTTP URL services could belong to one big IP. Yes, because one server could actually be a home, the hosting for many websites. So what is a web, folks? What is a web? It's not like internet. It's different. So if the internet is a telecommunication skeleton, it's actually basis of telecommunication. But World Wide Web is the system of information access based on the shoulders of internet. How do you like this definition? So you have access to information, and the system with browsers and search engines is the system of World Wide Web. But without information facilities like telecommunication things, we cannot actually create World Wide Web. But without World Wide Web, the internet will be useless. Only email send and receive. You understand, right? So, folks, two great things: indestructible telecommunication systems of worldwide named Internet, international network with protocols, with telecommunication facilities and everything else like this, and actually information delivery system named World Wide Web. That is actually all I wanted to tell you at this time. Folks, I would like to urge you to go to network description in Blackboard and to see actually what is there. Understand today's lecture better than you understand it now. But I hope it's quite clear.